name is Nolte, and today, as Anyan said, I am here for the Love of Biotechnology. So this speech is going to be a bit of an overview, so please feel free to ask any questions at the end. So to start us off, what is biotechnology? Well, biotechnology is the science of using organisms, systems, or processes, specifically biological ones, to develop new products or processes that can address societal challenges or to improve the quality of living. One of the earliest examples of biotechnology is fermentation, which humanity has been using for just over 6,000 years. And to start us off, the best example is beer. So beer brewing makes use of fermentation to add flavor and alcohol to the drink. And to make this alcohol, we first release the sugars from a grain of our choice through soaking. Then these sugars are added to hops and the two are brewed together. Then the yeast is added to do its magic and begin the process of fermentation. Now, after that, the beer is ready to drink, ice cold, maybe with friends. So yeast is an example of biotechnology because yeast itself is a single-celled fungi that breaks down enzymes. And using biotechnology, we can engineer the genes in yeast to modify its natural processes. So for example, it'll still ferment the sugars from plants, but into biofuels and renewable chemicals instead of alcohol, which is probably a bit more useful. Different subfields that are categorized by their application and then labeled with a color. So in our beer example, that would fall under yellow biotech. But today specifically, I want to focus on red biotech and gold biotech. Red biotech. That basically just deals with the development of medicines and treatments and often includes genetic engineering. Whereas gold biotech is about the solutions developed using computational sciences. So this will include things like bioinformatics, which focuses on analyzing large sets of biological data. So gold biotech will also often rely on machine learning or algorithms or very large data sets. So a large part of biotechnology today stems from the discovery of DNA. Gregor Mendel had already published his work on pea plants, proving the law of inheritance in 1866. And since then, we had been somewhat aware of DNA. However, in my opinion, it wasn't until the 1980s when CRISPR sequences were discovered on the E. coli genome that we truly realized what DNA was capable of. The development method for genome editing based on the CRISPR-Cas9 technology was actually awarded the Nobel Prize in Chemistry in 2020. And for the first time in history, the Nobel Prize was awarded to two women. So happy Women's Month. The women awarded were Emmanuelle Chantier and Jennifer Doudna. So genetic engineering. This plays an important role in another invention I want to talk about, which changed the lives of so many people, insulin. So before insulin was really discovered, people with diabetes didn't live very long. The best doctors could do for them was to put them on very strict diets with very minimal carbohydrate intake, but that didn't save them. It could buy them a few years, but ultimately they would succumb. Then, in 1921, a young surgeon named Frederick Banting and his assistant, Charles Best, figured out how to extract insulin from a dog's pancreas. They proved it worked after saving the life of a 14-year-old boy with an injection of this newly extracted insulin. And due to similarities to our own insulin, and insulin from livestock was used for many, many years and saved millions of lives. However, it still wasn't perfect, as animal insulin could often cause negative immune system reactions or allergic reactions. So over the years, changes was made to this animal insulin to make it safer, to make it slower release by adding fish proteins of all things. Like, we did try to improve it. Then, in the early 1980s, biotechnology revolutionized insulin synthesis. Researchers had already decoded the chemical structure of insulin in the 1950s, and they soon determined the exact location of the insulin gene at the top of chromosome 11. By 1977, a team of researchers had spliced a rat insulin gene into a bacteria that then started to produce insulin. Crazy, right? So in 1982, the Eli Lilly Corporation would produce the first genetically approved pharmaceutical product, human insulin. Without needing to depend on animals, researchers could produce this genetically engineered insulin in almost unlimited supply. And it also didn't contain any animal contaminants. So the concerns of transferring any potential animal diseases was completely removed. Explained very simply, it's a cell factory. We take the insulin producing gene from a human pancreas cell and put it into the DNA of an E. coli bacterium. This E. coli will then sit in a big fermentation tank and multiply, and then we can extract and purify this insulin from this fermentation tank. Much like we do with yeast and beer, right? But to do more amazing things like this, we need data, and a lot of it, which is a huge challenge ahead for biotechnology. According to Forbes, 90% of the world's data was generated in the last 2 years, with 2.5 quintillion bytes of data being created each day. This then leads to a problem where the interpretation and processing of data falls behind. And not only do Facebook and Google and a lot of other big industries face this, but the biotech industry as a whole. A single complete genome sequence can be multiple 100 gigabytes in size, and not everyone is capable of dealing with such a large amount of data. This therefore requires a very specialized skill set, and it's also quite expensive to do. If you wanted your genome sequenced, as of 2022, the price could range anywhere from $400 to $1,000. So this is where bioinformatics comes into play, and this would fall under gold biotech. So bioinformatics is an interdisciplinary field that develops methods and software tools for interpreting biological data, in particular when those data sets are very large and complex, much like with DNA. The most commonly used languages for bioinformatics is Python and R. And with the massive advancements in information technology today, bioinformatics is growing at a rapid pace and providing new ways and approaches for interpreting this huge sets of data. Data mining and manipulations is also an important aspect of this, and it allows researchers to collect and store and catalog and analyze these data in very unique formats that we can then also manipulate in future research efforts. But computers aren't perfect at organizing this data, and they make a lot of small mistakes that can also corrupt subsequent analysis. To double check everything could take a lot of time and manpower, which is something that a lot of researchers already struggle with. So what's the solution? Well, developed in conjunction with McGill University, Massive Multiplayer Online Science, and the Microsetta Initiative, they came up with a solution that utilized the massive player base of the well-known first-person shooter game, Borderlands. Borderlands 3 released in April of 2020, with over 8 million copies sold in the first 6 months. Near the end of that same year, a free update was released that gave players the opportunity to play a cute little game, Borderlands Science. It presents you with a simple block puzzle based on the nucleotides in a strand of DNA. And by solving these puzzles, you're helping to map and compare the microbes within any given strand. So by compiling the millions of matches that players are making and then feeding them into a sequencing algorithm, the project hopes to build a higher quality body of data and to map the human gut microbiome specifically. Solve this complex task is actually very simple to understand. Colored tiles representing different nucleotides appear on a grid, and by nudging them up and down in the columns, you try to align them into the correct rows. It's not always possible to line them up in the correct rows, but attempting these puzzles is still helpful as you're helping to spot errors in real-world computer analysis. As of May 2021, 2 million active participants solved at least one puzzle. The top 5 weekly participants had contributed more than 3,200 hours to the game. 81.2 million puzzle solutions had been submitted, and a total of 184 years worth of game time had been spent in Borderlands Science. Oh, sorry. So after only 1 year, thanks to the contributions of these players, 84% of the original mapping had already been completed. That is insane. So in conclusion, biotechnology is very old, and yet every day there are stories coming out of researchers doing the most insane things with these weird, complex data sets, and it awes me every single time. Biotech is in every aspect of our daily lives without us even realizing it. So we already have insect-resistant corn. We have glow-in-the-dark pets. We have the ability to 3D print life-saving organs. Who knows? Maybe one day a real-life Jurassic Park could be in the works. There is just so much potential in this field. Thank you so much for your time.